while developing products and solutions during the design of the product. To select exactly the right solution, we have to apply, we need for the welding. So typically, we make a cross section. This is something that we can manage in-house, okay? So we ask, if we can, of course, typically, we ask for samples. We kindly ask samples, to have samples from our customers. Please give us samples to make trials. Please give us samples close to the final production, because this is not so also easy to get. Sometimes they give you something only to perform some tests. But it's really important because, as we said, laser technology is extremely rigid in terms of boundary conditions. So we have to fix boundary condition. When we fix boundary condition, that's it. The laser is 100% reliable. So no problem, no doubt on that. Typically, we are struggling because those boundary conditions sooner or later will change. And this belongs to the, let me say, to the process, okay? And so that's why sometimes we have to say the real problem for a system integrator is not related to the kind of technology we're using, but with the kind of process and also variables, we could say, are coming during the development or the production phase. P4, this is a green laser, we could say. We use typically for copper. And it's something that we use, for instance, for copper when we go up to 0.3 millimeters, and also we can go up to 1 millimeter, even a couple of millimeters of copper. We use this kind of technology. And it's a technology that is able, of course, due to the wavelength that is below to infrared, to penetrate deeply, a little bit more deeply into the material, and is used by months for the copper. Also for solutions that are related to, for instance, inverters or cells, bus bars that we currently have. Typically, copper is well known as a conductor, so is widely used in the production of batteries, not only. And so typically it's something that we are facing, and in terms of, let me say, requirements. And okay, so we could say last but not least. So this is a kind of, let me say, additional information we want to give you, because we said we are machine manufacturers, and also we are system integrators. So it means that we are able to provide full lines, okay? For instance, if you have to start making batteries, we talk about gigafactories, for instance. So a gigafactory, typically, the gigafactories that are growing at the moment, sometimes are only renderings, you can see, but typically, sooner or later will come, of course. And they are asking us to provide solutions starting from the raw material. And so that's why we use laser system like ablation and notching, as you can see in this video. And so we make also machine to make cells, okay, whatever it is, could be prismatic, pouch, or cylindrical cell. And also the next step is to produce modules, okay? And this is something that could be integrated. So we could have for instance, two separate buildings where we assembly cells, only cells, and then the next building is dedicated to produce battery modules, okay? Sometimes they are connected, so in a kind of in the same environment, but these belong to our core business. So, and also we are very happy because there's a lot of, let me say, movement around this business, and the potential, of course, is really high. Sometimes we're struggling because of requests, because everyone wants to build batteries at the moment, so we have to face with problem of capacity, of course, and but it's nice to work having those kind of problems. And so this is something we can provide. I do not have other information. I will be happy to answer to your question if you have. Otherwise, we can have discussion maybe later on. So feel free to ask. And so thank you very much.
Thank you very much, Mr. Balugani. We're a bit ahead of time, but it was a very, very interesting talk, and it was very good to see how much laser there is in a battery. So thank you for showing us how much laser we have.
Okay.
Maybe we can have a very short question because we're a bit late. If there is anything that is pressing that we need to address immediately. Maybe we can, I will have questions for you maybe during the lunch
very
break,
good.
but
okay.
we can maybe try to get back with the timing. Thank you very much for this
You're
very
welcome.
nice presentation.
Thanks. Thank you.
Thank you. So for the next speech, we have a slight change, but once again, it's a privilege to announce this name. Professor Luca Tomesani from representing Nextama this time, which is another very interesting company coming out from university, showing how much university research can actually have an impact in this sector. So, Professor Tomesani.
Thank you very much, Mr. Chairman, and good morning, everybody. I'm Luca Tomesani from the University of Bologna, and I'm here now to represent Nextema for Lorenzo Ceccon, who could not be here today. Nextema is coming from a startup experience. Now Nextema has grown in application. So the company has established in 2015 in Bologna, and is a classical company that gathers all the experience of researchers over many years here in Bologna, and it brings this experience in the field where you still need more knowledge to develop in a special field, in the industrial field, when the researcher, the university researcher, is no more interested in develop. So to do that step more that is really needed in the laser field. The company is doing a lot of things. He is very active on hardening and cladding. We have two plants, and one is really here at the BREX Competence Center facilities, and the other plant is very near here again in the Nextema industrial site. Having this experience, where normally the company has a lot of flexibility, and so the typical work they do is to keep the problem from a customer and develop the specific application, whether on hardening or cladding. And in this case, I'm going to talk about welding, of course. They also have some additive manufacturing facilities, but this is not the main theme. What Nextema does is, first of all, to integrate laser facilities and automation for manufacturing plants, so turnkey plants. They also do revamping in existing production plants, so they can put some lasers on classical CNC machines. they do prototype manufacturing, and at the very end, they also do, more recently, production for third parties. What I'm going to talk to you right now is the Nextema approach for the battery pack welding, which is an interesting theme. We have seen this morning how complex is this field. And Nextema approach is very specific. We divided the problem in two parts. The first is about the evaluation of general process feasibility, not just so immediately work on the battery pack. So there is a first phase where different welding strategies are evaluated, and at the end of this first stage, they are going to give an intermediate report on which is for them the best welding strategy that can be adopted for the particular problem. Then they go on the battery pack, and the welding strategy is applied to the battery pack, being care of all the problem we already have mentioned, and I'm going to talk a little bit more on that later. Of course, in each of the two stages, the welding sections are checked in order to understand, and at the end of this, they are going to give a final report on the battery pack weldability. After, at the end of that, if needed, they can do small series production, and if needed, again, supplies a customized production unit. Coming to the evaluation of process feasibility, I have some images here. It is of utmost importance here to clear what kind of laser and laser can be used. They work mainly on near-infrared, but they're going also single mode and multi-mode. But also they're going to use the blue lasers. Also, depending on the thickness of the elements, focal length may be varied from short to long. Welding strategies, as you know, are very important. They may have. It is possible to adopt a linear or wobbling, in some cases, pulsed strategies. Here on the other side is a clear figure of very simple elements that we may use in the case of cylindrical cell, in this case, in order to have samples that very clearly represent the ideal condition of a welding. Some images of the work done on this copper and aluminum and copper with short and high focal length, with linear, with wobbling, and after that, in each case, it is possible to understand the mechanical resistance, the electrical resistance, and these activities of checking we do in combination with universities. Some activities on CU steel electrodes, which can be nickel-plated, and this also affects a lot the process itself. They worked also on 3 layers configuration, 2 coppers on coppers and aluminum on copper, and so on. There is a great world on this, and all this world on this application requires a specific work to be done. And again, aluminum on aluminum configuration for cases, and again, prismatic cells. This slide would like to understand the kind of work is done, because coming from we are process engineers, and as process engineers, the idea is to find the feasibility area of a process, keeping in mind that, of course, the bigger is the feasibility area, and the best will be the process at the end. Also, taking in mind that going from the very small number of a prototype to the big number of a general production, of a mass production, the production chain will change. And most probably you will have to consider that the element that you're going to weld in the very early condition are going to change a little bit. For example, you know that a classical sheet, a metal sheet, is going to have variation in thickness of about 20% normally. You will have variation in the elastic modules of the materials. You will have change even in chemical composition. So, taking in mind this, when you're doing your experiment on the very first material and you're finding a position that you like it, you have to bear in mind that these conditions are going to vary when the number are going to increase. And so in this first part of the NextEma approach, I would say, the idea is to put ourselves in the center of an area which is big enough to ensure that when the number are going to increase, you can still have good results. Of course, this also applies to hairpins. We have done some experience also on hairpins, and here again the same concepts applies to hairpins. So first we have to find a good weldability area, and after that we're going maybe to optimize performance within that feasibility area in order to have the best mechanical performance and electrical resistance also. Okay, this is a sketch of an NextEma brand new prototyping welding cell. It is a cell where we can apply many different lasers depending on the application. The cell has the classical 3-axis system, so it's very easy, with a galvo head with 2 axes and a pointing camera, automatic adjustment of laser focus and control software and so on. A deeper focus here on the cell, and maybe with the elements you may see very clear here. It is to mention the fact that the cell has a feature recognition camera, because you have, of course, to be very to easily find the point to weld. There is also a position sensor that adjusts especially in the short focal length application, the focus for each welding position. This is of utmost importance, of course. And also here it is possible to see the battery pack position system for the specific application in this case. This is a very simple welding cell. We can do almost any kind of battery pack, so cylindrical, prismatic, and pouch, and so on. This is a courtesy from the University of Bologna, which is also developing its own battery pack with another startup company. And this is an application where we could develop the process and apply this approach on this battery pack in particular. This is something I would like to show you. It is the section of the upper elements placed on the lower one. So it is. We have just heard about how important is the perfect contact, the no-gap condition. So when someone comes to NextEma with a particular condition, NextEma must know, manufacturer must inform NextEma about the exact location of the available contact of the two elements. this is something that is not very clear, as I already heard from a previous presentation. Not always the customer has the knowledge of how important it is to have a perfect contact condition. And this is a section of the previous one, and you see that even in the width, along the width, you may have gap or no gap condition. And so you must check very carefully where you have the good contact, and in that area you're going to apply the process that you have studied before. So in this particular area, you are going to apply the strategy and to produce some welding with length and width that are going to define the final resistance of the joint in terms of mechanical and electrical resistance also. This is a very last sketch about what Nextema is doing in this field. They are adopting a laser blue source, in particular for copper application, of course, due to a higher absorptivity index and more stable melt pool. And they're also integrating sensors in artificial and intelligence environment for early failure detection. So, thank you very much. Thank you.
Thank you very much, Professor Tomesani, for staying right in time, the academic way. Thank you very much. So this is an excellent example of the research discipline coming to a company. So congratulations on this achievement overall. Let's see if there are any questions from the audience in the meanwhile. Maybe to start the discussion, I can take the discussion back to the idea that we have a lot of applications, a lot of configurations. So apparently Nextema is able to benchmark, show a lot of results. So there's a lot of process knowledge. So if you can give us a bit more insights about how it works prior to starting the process development, during, so these showing to a potential customer the numbers, the examples, because we kept speaking about giving out people, releasing a bit more information.
The work is, of course, a complex. Laser, I heard this morning, is very vast as an industrial sector itself, and also the manufacturing fields is really evolving. So it is not really always straightforward, the solution you have to adopt. I mean, sometimes you have something in your hand to give immediately, and sometimes you have to think and to develop and to co-develop very often the project together with the customer. It is, I think, also the everyday work, because materials are evolving, and as I said, also the number and the production chain is going to evolve during the work. So very often you have to work from the beginning along the whole development of the strategies with your customer in order to give a good product. And this is what they're trying, what Nextema is trying to do. So is to work together with end users and collecting things in order to achieve this. Thank you.
Let's see if maybe I can ask another question that is not immediately related to lasers itself, but so we're in Bologna, Motor Valley is nearby. What is the influence of this region? What is the influence of this region, the city, to developing mobility applications, because we see that there's a lot of movement happening. So how is the relationship between university, company, and the whole ecosystem?
The relation is really excellent. Here, I thank you for the question, because we are in BRX, which is a fantastic place to be. BRX is a consortium of research centers and not just universities, but also of many, many companies. After 3 years of founding from the ministry, we are going to have 3 more years with a very important foundation of collaborative research to do together. The idea of BRX is to put together, and this is also very interesting for what we are discussing today, as we want to understand and go more quickly into developing some results. So the idea is to form groups of companies, small groups, 3, 4, that share a common problem and be founded from the ministry and work together with the university. This is a very interesting way of solving problem really fast, and we're going to see. Of course, BRX is open to everybody. Now I'm talking for BRX, is open to everybody, and is open not just to companies that are associated to BRX, but also to external companies. So it is a very free and open environment to work. Thank you.
Thank you very much, Professor. So
Thank you
I
very
guess
much.
This is good enough for us. Okay, so the last speech comes from Anisa Kapsiu. She's from Marpos Electrosystem. Sorry? That I pronounce your name wrong. That happens to me a lot too, very often. I'm very sorry. I'm very sorry. I understand the feeling very well. The floor is yours.
It's not a problem. Good morning to everyone. I'm Anisa Kapsiu, and today I have the pleasure to be here, so thanks a lot to the BRX organization. I have just the question for the future. Maybe could be present other women here, because I have seen a lot of beautiful women, and some of them I know that are competent, so this is my question for the next session. Maybe it's possible. Thank you. Today I have to introduce you our solutions about electrical testing in modules and pack battery system through Marpos Group. For who knows him, Marpos is an Italian group founded in 1952, and it's close to here because the headquarters of the company, of the group, it's in Bentivoglio. We are leader in quality and manufacturing process control with really several tools for measurement technology in product environment, but not only, because we are present in the lab. We have more than 80 offices in all the world, and we are present in more than 34 countries. Over this, you can find in our group 3,500 persons, employers that works today, every day, in the solution, in dedicated solutions and in dedicated product in every kind of metrology control. And I'm an R&D department engineer, and I want to focus your attention in our investment for each year in 8% of our resources in R&D development. And we are present in several industries, because you can find Marpos in automotive, aerospace, glasses industries, white industries, and so on. In this moment, it's very important to have specified qualities, skills in several fields of this EV new industry that is growing up. And for this reason, in Marpos are several companies that can give you solutions for gouging and inspections in our headquarters in Bentivoglio, or with leak testing for the battery solutions in MG company that is located in Brescia, or for all it concerns the electrical testing of battery systems, so module spec or just a battery cell level in Electrosystem. This is my company. We are located in Asti, close to Turin. Or for the electrical motors in our other company of the group, the EDC, that is located in Milan. Least but not last, because in these 2 days we have just talked and we have heard something about the fuel cells, you can find solutions for not only the electrical testing, but also for the leak testing with helium technology in HETEC company for the fuel cells. Marpos can propose a really key solution for the end-of-line testing machines, like is represented in the picture that you can see in this slide, or the beginning-of-line testing machines when we are talking about the first step in the module composition assembly. Solutions for cells grading and sorting, that it means not only the mechanical, so the mechanical part of the machines, but also the software development of it. The installation test, like just a station, a standalone machine, or integrated inner line. The BMS communication testing, and of course, the dimensional check and leak testing of these components. Electrosystem comes from automation lines in assembly and testing, so the concept that we can give our lines, our machines in module and pack testing is this one. It can be divided in 3 principal benches, in which maybe I have no time to show you every component of it, but I want just to focus the attention in the safety aspects, because it's very important to have safety like the first main characteristic in the lines, not only for the components that we have to process because are live objects, so the cell, it's not like the other mechanical parts, but also for the man, so for the interaction of the machine with the environment. For this case, we use different devices for the objects, like thermal camera or sprinkles, but also it's important to have a fire protection for the man, for all the line or the station. Also, our present automation, it's important to have the function that needs in the line for the testing. For the testing, just for electrical testing, maybe this is the first slide in these 2 days where are present the electrical testing that usually are be done in the modules and in the packs. So the instruments that can be integrated in our machine, but also it's a logical hardware bench composed by the CPU, the HMI, or the interaction of the machine with the external environment. We have just yesterday talked about the analyzing of the data after the process. And of course, the main topic of these 2 days is laser components and laser applications. It's possible to have a product in Marpos for the laser applications. So we have the machine that can provide the laser welding joint. But in this case, the focus and the goal of this presentation is to show how we can identify a really good, for the electrical aspects, a really good joint. This is possible to have measuring the resistance of the joint, so measuring the resistance of the contact. Maybe we have heard something in the first presentation of today, and to see that the electrical aspects, so the functional electrical aspects of the components are really good through this very important technology in the automotive industry, in EV industries. We want to show our solution of the bus bar laser welding control through a really case study. And for this case study, we have a module composed by the cylindrical cells. Of course, are present some target by the customer, like the positioning, the reference points, the internal resistance, and also, like you can see here, the first target for the end customer is the time cycle of the process. So it's very important to be faster when you have to control something, not only when you have to weld it or to process with it with the laser technology. For this case, we have 78 seconds to perform all the cycle with loading and unloading operations. The contact resistance measure is done with the classical traditional method. It's called the Kelvin method, with 4 points contact on the components that we want to measure. Maybe this scheme here shows the 2 contacts that leads the current in the components, and after we have 2 other sensing contacts for measuring the different voltage in the component. This test is possible to be done, to be performed, if we have space to do it. So it's necessary to have a little bit space between the bus bar and the terminal of the cells. If not, maybe it's not possible to perform this test. And the other problems that maybe can be present in this test is the scratching that are introduced during the sensing, maybe here. And the other aspects that the integrators and the builder lines are usually to perform every day, for example, the length of the wires or some mechanical adjustment that we need in the machine. The classical method for this module is concerned in a plate with all these contacts that we have to put in contact with the terminal of the cells. And there are a lot of many contacts present in this plate, in one plate. So in this case, we have 520 contacts. There are just some critical issues with this approach, because just a problem with one of the contact obliged to have a stop for all the line. So we have to stop the machine for changing just one contact. We have maybe to replace all the contacts that are present in the plate, and we are talking about 520 contacts, so time, you have to keep in mind the time and the cost of the spare parts that are necessary to do this operation, and of course the possibility to have the right position of the wrong contact. It's very hard, because you can recognize a bad contact only over the repetitive scraps. So you need to have some scraps before checking your machine and before having the decide that you have something wrong in the contact plate. What we have to propose today is something really compact, monolith, and customizable, because it's just a robotized basic bench in which is present a solution for contacting just a row in this module. So we have all the operation done in this part of the cell in automatic mode, and just the loading and unloading of the modules in manual mode. The composition of the machine, it's really easy because we have also the fixture for the module, but after that we have block gripper of our robot in which are present 5 contact blocks for each terminal of the cell, and we have another storage unit with a rotary table where are shown in red the scraps block contacts that are used by the machine, and in the green the buffer of the contact blocks that can be used during the machine, during the process, sorry. The main characteristic of this solution is just the gripper that I shown before, and the gripper is very compact. It's possible to introduce in it all the electronic devices needed for this control. And the other main characteristic of the machine is that the replacement of the contact block can be done in automatic mode. And of course, each pogo pin, so each terminal can be replaced in offline without any stop by the machine. In the end, I just leave the other very good solution, in my opinion, for this concept, that it's the reference gouge. Like I show in the traditional solutions, you have you have more scraps before understanding that you have just a problem in a contact. In this way, you can freely program the machine to check all the time that you want, all the one per shift or something else, all the contact blocks in automatic mode. So, for example, during the loading and unloading operations of the modules, it's possible to check if the contacts has a good characteristic for measurement, the micro ohm that are required in this application. I was very quickly.
I think.
Thank you for your attention.
Thank you very much, Anissa. You were very precise, not quick. Precise with time, so thank you.
Oh, good.
Thank you.
Oh, yes.
So I think this was a very interesting speech, which shows that under the hood of a company, if you have both the machine and the measurement, you go towards functional analysis. So this is very interesting to see that we actually test the electrical behavior of an electrical device right on board the machine.
Yes, it's very important to match all the competencies and all the skills that we have, because someone this morning asked what like laser builder can I offer to the industry? I think nothing. We have to go together in the same direction for having a really good solution and a really good target for the market. In our companies, this is present because we are several companies, and it's important to exchange our knowledge by each other. Without this, it's not possible to go on and to have really good solutions.
I agree. In my humble opinion, that's what we try to say. Do we have any questions? Maybe I can ask a question.
Yeah.
Because in laser welding, what we do is we weld and we destroy. So we develop the process.
To qualify it, yes.
To qualify it, it's a long process of make so that you can destroy. And actually, the tests that we do are not functional. We look at the seam size, porosity. Actually, these are all proxies of electrical behavior. So the device, would you use it for process development as well? Not only for process control. Say that I use my process parameters to reach the desired electrical behavior?
I think you can use them both because you need to have the monitoring of the process for knowing what happens in your welding bead. Yes, of course. Maybe you can correct something in the process before, like we have seen, for example, for the stripping. If you haven't a good weld, it seems that maybe you have just a problem before. In the same way, you have in the post-process other checks like really functional of the object. So you have to see the performance. When we talk about the module and the pack, the electrical performance of it are the first aim. So it's important to have something that can test them fast, yes, like the laser process can do the weld or the strip or the cut, and of course really automated in the machines, because it's not possible today to have a standalone machines. You need to have an interactive line in the full process of all these components.
Do we have any other comments, questions from the audience? I guess not, but going back to yesterday's discussion, we spoke about, just as a final remark, interconnected machines and so on, but you still want engineers who know how to use lasers, right?
Yes.
That's what you said.
The first one.
Okay, thank you very much.
Thank you too.
Okay, so with some accumulated delays, we come to the end of this session. Thank you, everyone, to our speakers, and to you who have been listening here and also online. Let's go to the lunch break, and perhaps we can start a bit later than as we have expected to do. Perhaps at about 2 o'clock we can come back to this room. Thank you.